Cool. So now the recording has started according to my Zoom like heads up display. Real quickly, this is a very similar way to how we teach and go through Python in our beginner course, our Python Foundations course, which is entirely free. If you like this experience, you have 2 evenings a week, 6 to 9 Tuesday and Thursdays is the part-time version of the course. As of right now, it's entirely free. Feel free to sign up, try it. Worst thing that happens, you stop after 30 minutes and don't really feel like it's for you, but you tried it. Again, it's free and easy to tune in just like this via Zoom and REPL.it, which is a great platform for this stuff. So if you're curious about that, let me know afterwards. I can put you in contact with someone who could get you on the list of who we would expect for that. Otherwise, it's similar to how we teach our second software development course as well, which I teach, which uses a combination of this and a cloud database to build a application, your first full stack end-to-end application, which is kind of a cool thing to do in another 4 part-time weeks. In the evenings, it is not exactly, but overlaps with some material we also cover in our immersive courses, be that data science or software development side of things with Python full stack development. While we use different environments and stuff, obviously for more professional experience, it's a very similar way to learn and it's very similar syntax and everything, honestly, that we would be using for the Python side of things anyway. So this is kind of a gateway to all of those. If you have questions about any of those, each of those courses starts about every 5 weeks. I'll mention them a little bit more at the end as well if people have questions specifically about data science, engineering, whatever. But I've probably, saved enough time for whoever may have joined late or maybe joining late. So I'm just going to dive into some syntax. All right. My first question here is always important, and I encourage you guys to use the chat if you can to answer some of my questions at least. I usually teach a very interactive way, which is a little bit weird via Zoom, but I hope using the chat is fine. Have any of you guys ever worked with or written any code before that counts things like VBA, things like R, things like MATLAB, if you've done it? Even some basic Python scripting. A lot of people have encountered a tiny bit of Python scripting before in some weird embedded application or something. I came to Python originally through that. I was in college. I was an environmental science major originally. I encountered Python as a way to, as a scripting language in the ArcGIS mapping software. And I decided that it was kind of cool and then ended up using it more for engineering and not at all for the mapping stuff. But if anyone wants to weigh in their experience or if they've ever done any kind of coding or written code, ran code before, feel free to throw it in the chat. Otherwise, if you guys won't, I will just continue on. There's one. There we go. We always have some VBA somewhere. Someone's always used it. Cool. JavaScript, all right, Python's like JavaScript, but I don't want to sound disrespectful to JavaScript, which is very useful. Cleaner. It's a good way for me to also mention that occasionally I type a syntax wrong. I will write let and then a variable name or const or something because I also teach JavaScript. I kind of teach both 50-50. Depending on what I've been doing that day, occasionally switching the syntaxes does take a few minutes. Apologies if I write some JavaScript. I will usually see it immediately, apologize, and then rewrite the line of code. If you who know JavaScript see me write JavaScript, you can always yell at me via the chat. That's fine. I'm used to it. But that does happen occasionally. Just bear with me. Anything that has curly brackets will be JavaScript, but we'll probably get a highlighting error here as well to say what the hell, Greg? I'm going to close this file browser over here. If you look at REPL.it, this great platform right here, it's free to use, by the way. They don't pay me anything. This side window here, we don't need it. We're only going to use one file today, so I'm just going to move this across to increase the real estate of my screen for me and you guys. If we look here, this is just a text file, which may sound weird, but it's true. Python is really just written in a text file. The only thing that makes it Python is the fact that I happen to write the syntax correctly in a way that the Python application or the Python interpreter can understand. So it's really just a text file though, right? It's just like .txt files, JavaScript files, whatever. The extension to the file means nothing. It really just tells your computer what application should open it. There we go. I just muted one of my tabs. There should be no more noises. But anyway, this is my main .py being the extension for Python files generally. And so to start writing code is actually incredibly simple. All I need to do here is just write any line of an expression, right? And when I click run, right, Python, meaning the program named Python or the Python interpreter, is actually going to start itself up, read my entire file, figure out what it says, and basically tell my computer to process or do what I told it to. All right, and to start out with in Python, before we can get to some real cool, write some code that does stuff that's really cool. Unfortunately, we have to start at some of the basics. So we're going to start with some of the basic data types. All right, and this is really a way that we can represent values. The simplest way to do it, right? Because computers don't really see values or difference between things that aren't ones and zeros. They're just like a weird, complicated grouping of switches and circuits and stuff. So we need to figure out a way we can group objects into like different types, right, that Python can understand and tell our computer what to do. So we're going to start out with some of the most basic types. That should make some sense. Anyone who's come from another language, you can probably throw in the chat some basic types. They all have a Python equivalents that are pretty obvious. If you've seen spreadsheets, right, we've all seen spreadsheets. The most basic types you've probably seen are going to be numbers and text, right? And I'm going to add comments through here periodically as well, so that if you get this code, open it tomorrow, Friday, Saturday, next week, next month, right, you will have some semblance of labels of what's going on. So Python has numbers, right? JavaScript, if you've seen JavaScript, has a capital N number type, which is just all numbers. Python for numbers has, broadly speaking, 2 number types. Technically, there's a few others that are more niche. We're only going to talk about the basic 2 today. So we have 2 things, right? Integers. So I'm going to say, there we go, the JavaScript. Our integer equals 8. So integers, right, which is just a number that has no decimal. So this is just going to be 8, 12, 9,000, right, 4,506, but not 8.2, right, or not 10.6, or not 0.3, right? Anything with the decimal point becomes a different type in Python, and this is going to be float or floating point number, which would just be any number that has a decimal point. And it's worth knowing that technically in Python, these are different types. Python treats integers and floats as slightly different objects, but realistically, they behave the same way. All right. So as I'm sure we can all remember from whatever math we've had to do in our lives, there's a bunch of specific mathematical operations. You could do like 8 plus 9, 9 plus 100.9. I'll change that to be minus, actually. All right, there's 7 divided by 5. So this is the division sign, right? /. This will give us something slightly larger than 1. 7 divided by 5. There's also multiplication. In Python, we use the asterisk for multiplication as our multiplication operator. So we got 4 times 2. This will be 8. Hopefully these operations all make some sense, right? Plus, minus, divided by, times. And if we run this, Python will happily look at each line and say, cool, we got 2 numbers. Here's an operator. Let's get the output. But in Python, just like JavaScript and many other languages, these on their own don't do anything. This tells our computer to make a calculation. And then once it's made that calculation, it's done. We don't use the value. We don't show ourselves the value. if you look up here, right on line 6 and 7, I actually use what's called assignment to a variable name, which basically says, I'm going to make up this name, and I'm going to put a value in it, right? Here it's 8. 8 is the value, and here 8.3 is the value. What this basically means is that now I can use this name to refer to whatever value I stored. And obviously this isn't incredibly useful right now. I could always type 8 anytime I could type our_integer. It would be faster. But later on we'll see that it can be a little bit more useful to do this, right? For example, we can say addition equals, right? And now the output of this expression, this is what we call an expression. Really, the way I usually define an expression is simply just any bit of code of ours that can be evaluated, and after which you can get like one value, right? So this is code, it's two different things in an operator. Ultimately, we can resolve this, get one value, right? We can get back 17. Same thing here, right? We can say subtraction equals, right? Here we're going to get a negative number, division equals, and multiplication equals, right? 4 times 2. And now, if I click run, again, we get no output. We don't see anything happen, but our computer performed all of these operations, and we could have used these values later. So the first way we're going to actually figure out any of these values is with Python's print function. If you notice, this name became blue once I typed it, right? Which here really just means this is a reserved word in Python, all right? And we'll see that a few times. Anytime something's highlighting changes like that from just the black variable names, it means that this is built into Python, and I should not use that name on my own. Technically, this is an important thing to watch out for. If I did something like this, print equals 90, print, the function that will show me something in my output or my console, would no longer work. It would instead be overwritten in my computer's memory by the number 90. So always important to create your own names not used in Python. There's only a few names used in Python, most of which are pretty obvious. We'll go through most of them today. So it's not hard to make sure you don't overwrite things, but you can always look at the blue highlighting as kind of like an error message, like don't do this, all right? So for now, I'm going to print and put in division, all right, this variable name. So this should show me the output of this expression, right, which I have assigned to or given this name. It should show it to me right here, right, in our console. So when we write and run code, generally we have two things we're looking at, right, our code itself, and then the console, which is where our computer may or may not give us the output we ask it to. So now when I click run, I get 1.4, all right, which is apparently the output of 7 divided by 5, all right? So you've got 1.4 here. So now we've kind of proved this works. I'm not going to print everything just so that this doesn't get too hard to comprehend as we go on, all right? I will also periodically comment things out. And by comment, what I really mean is, right, this is the pound sign. In Python, the pound sign, right, shift 3 on your computer denotes a comment, or really a line of text that isn't supposed to be executed. This is usually used for two reasons, right? The responsible reason for comments is to sort of show people like things about your code, right? I have some comments here, one welcoming us to today's webinar, and then a bunch of comments just denoting lines, what the following lines are going to be about. But a comment is usually used to document your code, explain to people what's going on. Occasionally, it's also used to get rid of code you don't want to run, but also don't want to get rid of. And frequently, when people are in the middle of writing code, they won't get rid of or like literally hit delete on a lot of it just because it may be useful later. they may be hiding it for a second to make sure something else works. Commenting really kind of fulfills those two ideas, but it's mostly used for documenting your code so other people can read and understand what it does. So now we've gotten through these numbers, right? These operators, which again behave mostly the way we expect them to, and the print function, which I'll be using many times as we go, just so that we can see what happens, right? See our outputs, because otherwise we don't, right? Again, my computer did all of this, but it never showed me what happened, right? It just performed these computations, and then it got to line 17 here and said, cool, I'm done. And that was it. These values were all out of my computer's memory. We were done. So it's kind of a way to say a variable name here, variable assignment, is like storing the output basically of some code you wrote or some expression or an operation you performed in your computer's memory so you can keep using it later. Or sometimes, like we're going to do today, just in case I want to reference it at some point or show it to you. All right. So these are two different types, right? These are both numbers. They're pretty straightforward. Coding is actually a lot less math than some people think it is. Most of the math has been written already by the developers who made each language. There's very little hardcore math you have to do unless you're like a quantitative developer. Engineering is like a limited amount of math, generally speaking. So rarely are you just using numbers, honestly. A lot of the time you're using a bunch of other data types. For example, in data analysis, there's a lot of integers, there's a lot of floats, but there's also a lot of text. There's labels, there's categorical information, there's names, there's metadata, there's things with a % sign at the end that are actually strings because the % sign is not a numerical character, all this other stuff. And so it's also worth looking at then Python string data type, right? Which is what we can think of as, you know, text basically, right? It's any collection of characters. And unlike an integer or a float, which is obvious, right? You type a number, that's it. You type a number with a dot and then another number, that's it. That's a float. A string is denoted by open quotes and close quotes. All right, again, this is very similar to JavaScript. Those of you who've seen JavaScript, probably many other languages as well. Even though I've never seen VBA, I'm assuming it's very similar so far. So a string has open quotes, close quotes. You can technically use single or double quotes. It doesn't actually matter. Usually people will pick one or the other. I generally use double quotes. They're a little bit more obvious because they're a little bit thicker and harsher. You can use whichever you want. The only thing that matters is a comment over here. This is not. So real briefly, this is a comment. You can actually put comments after lines of code. It can be helpful for a quick way to document one little line like this. But really what I'm trying to show you is you can't close a string with a different string character, right? So if I start it with double quotes, need to end it with double quotes. This is actually just a string that has a single quote character in it and never terminates. And believe it or not, if I run this code, I'll get an error, which is just, right, end of line while scanning string literal. This is just a Python syntax error that says, Greg, you didn't close your string. I have no idea what to do. You'll get used to this probably if you continue on playing around with Python. I usually tell people the debugger is not bad. It's not telling you that you're bad at Python or wrong. It's helping you, right? The debugger is helping you write Python better or help you fix your code, because nobody, even people who've been writing code for like 50 plus years, don't write it correctly the first time. It's just not really a thing anyone has ever done as far as I know. So the debugger is just there to quickly help you, kind of like, you know, Microsoft Word's got the red underlines, the grammatical underlines, same idea, right? It just prints it here, shows you the line, shows you where the issue was, and then you can fix it, right? Here's line 17 at the end. But you can use either character, right? Again, I use double quotes if you like single, that's fine. A lot of people do. A quick note, right? A string can really have almost any text character in it. You can also have numerical characters, right? These are not numbers. This is technically like the character 9, not the number 9 or the value 9, right? Important to remember that. Also worth noting, punctuation characters work, except for these quotes. You got to be careful with like including a double quote in a double quote string. It won't work. And also things such as the fact that a space is just a character, right? So here we have a spaced character in the middle of our string. That's fine. It's just a character. People aren't used to thinking of that as a value, but it kind of is. So these are strings, right? These are kind of the 3 most basic sorts of data that most people interact with when they're starting out coding, trying to learn a little bit of coding to help them, right, at their job or processing data, right? Most spreadsheets are comprised of those 3. REPL periodically saves. It is what it is. But so here's these 3 types, all right? Really quickly, before we really jump to strings, I want to also mention a few more complex mathematical operations, all right? So we also have modulus division equals, let's see. So I'm gonna print this. No, there's a space, that's why, cool. Cool, so we get 0, oh, I chose literally one random number that didn't work. Cool. So we get modulus division, which is basically remainder division, right? This is how many times, this is the remainder, right? So 28 goes into 50 one time with a remainder of 22, right? So modulus division gives us the remainder. Floor or integer division. Some people hate people who call it floor division. I call it floor division instead of integer division. Floor division is the opposite. It gives you only the whole number of times one number divides another. So floor division here, which is signified with 2 forward slashes, so 2 division signs in a row, in fact, gives us 1, right? The whole number of times 28 goes into 50. If I change this to be 50 and 8, we get 6 times, right? Because 8 goes into 56 times. Then this remains unchanged as 22. All right. So these are mathematical operations that are worth remembering, mostly because they actually become very useful a little bit later when we're looking at things like divisibility, which can be useful tools to us. Finally, anyone who's used code before might know this, but it's worth also looking at the fact that your computer is, it's worth knowing your computer's imprecise. All right, so can anyone guess what the output of this is going to be? 0.2 plus 0.1. Take a wild guess in the chat if anyone wants to. One of you might have seen this before. All right, if no one wants to put it in the chat, I'll just run this then and show you. So 0.2 plus 0.1, we're probably expecting, right, 0.3, right? That's it, just 0.3. We actually get this, which, like, Greg, that's basically 0.3. Like, it's almost entirely 0.3 to the point that I wouldn't be able to notice. Why are you saying this? This can be important, right? Technically, the way your computer stores these values and does the math is a tiny bit imprecise, right? It's like, without counting in front of you guys and boring you, it's like 14 or so decimal places precise, and then one extra one that's not. This isn't important for most normal beginning calculations. It can be important, though, if you're trying to represent things like money, right? You can't have financial calculations creating ghost money that doesn't exist and then causing, large errors. That would be bad. Things of that nature, right? It's worth knowing that even your computer and how it stores these numbers isn't perfect. So generally speaking, in Python, we actually have a different function. I'll get to what a function is specifically a little bit later. A round function. which will basically just take an input, round it to a certain number of decimal places. So, so it takes two things, right? It takes an expression, is the first thing I give this. So you get 0.2 plus 0.1, and then a number of decimal places, which is going to be like 3 probably works. Now it'll give me just 0.3. Technically, it could have given me 300 if I needed to. All right. And that will take it away, truncate the number so it is represented correctly in memory. It's always worth remembering that. But as we scroll down here, right, we can also start looking at these, these strings, right, which is sort of, again, like text, right, really how we can look at text in Python and manipulate, programmatically change it, do cool stuff with it. Text supports many of the same, or strings support many of the same. I'll change this identifier now. Operations, believe it or not, as numbers, they just don't give the same output. So for example, if I were to print like A plus B plus C, right? There is no mathematical way we could add A, B, and C and get like F or L, right? That makes no sense. But what plus does, the plus sign with string characters, is simply add them together, right? It concatenates them into one string. So we get back functionally the equivalent of the string ABC. All right, so it just adds them together into one string of the same 3 values. We can also use, and I'm going to use my name here, Greg. We can also use the asterisk operator as well, although this behaves even weirder than we might expect from, well, it actually behaves very similar to math. The asterisk here is actually going to be like the repetition operator. So we're going to get not just this string, not a changed version of just that string. It will just give us that string 6 times, right? Which is important to know if you're trying to use and access strings. All right, so real quickly, I have this string up here, right? Our string equals this to string. In addition to using a string like this, we can also, I'm going to start using the variable name, right, to reference it. Just know that, again, every time I use our underscore string, I'm in fact referencing this string on line 21, specifically this string, right, all these characters. So with a string, you can, if you want, get specific characters back if you so desire. So if I want the first character of a string, I can simply type in a position, right, an index position, which actually, this being code, always starts at 0, which is a design decision made a long time ago about code, pretty much every language. So Python starts everything from 0, not 1. So the first element is actually index 0. Second element is index 1. The 7th is index 6. It's just the way it is. I'm going to wrap this in print real quick. So this should give us, right, our string 0. So it should be the first character, right? That should give us back lowercase t, right? And if I print that, we get back lowercase t. All right, I can change this to be like 6, get the 7th character. It should be 4, 5, 6, 7. So it should give us a lowercase s, which it does. If I finally go with index 7, right, the 8th character is a space, which does print. You may not see it, but it's there, right? It's printing us a space for us. It's just less helpful. So you can access characters like this, or we can do what's called get a slice, all right, which is pretty similar, except the way slicing notation works is we don't get one character. We get everything from one start to a stop, all right? So for example, let's say I wanted characters 2 through 6 of my string. right? Or the second character through sixth character. So the second character would be index 1, the sixth would be index 5. In Python, you can just separate them with a colon, all right? So this is now going to give me not just one character, it will give me one indexes 1, 2, 3, and 4 with the stop not included, all right? So if I run this and give it the correct R that it needs, I will get back HIS, space, right? So I'll add 1 to this so we can see not have a space at the end. Cool, right? So it ultimately gives me characters 2 through 6 of our string. All right, again, not including this index position. I can also leave the second argument blank. This will go from a start to the end of the string, right? So this is actually going to give me everything from here. It will automatically imply, right, last character. Same thing works this way. If I leave no start but put in the colon, it will start at the first character, go up to, but not including index character index 7. All right, so we get this is. If we really want to do something kind of weird, we can add a third argument to the slice, which is our step. So if I put a 2, here we're actually going to go through and we should get, this will give us every character of our string from the beginning, right, as if there was a 0 here, up to but not including the 8th character, but we're going to go by 2, so that's going to be every other character in our string, all right, which is kind of weird looking, but we get a first character T, we skip the H, then we get an I, then we skip the S, then we get a space, then we skip the I, and we get an S. All right, so that's kind of how that all worked out. So this is our weird output, but it is possible, right? You can do this. It's not always useful. It really depends on the string you're processing and what you're doing. All right. So these are some basic string operations worth knowing. Python also has a built-in method of strings that lets you sort of dynamically change what they say. When I say method, I really mean a function, right? Here we have seen functions. We've seen print and round so far. A function is really, you can think of it like in elementary school, right? It's something that can take an input, do some sort of calculation, and give you an output, right? It's a reusable bit of code. The syntax for a function in Python is basically function name followed by parentheses, right? And in here is going to be inputs. So basically, you take your function name, you give it parentheses with no inputs. We can just call it with no parentheses. So print with no arguments will just print us a blank line, but it works. Otherwise, parentheses always encapsulate your inputs so the function knows they're coming in, all right? But there is a method just being a function that is owned by a specific type. So when I say that, I mean there are string methods, which only strings can call, which only work on strings, and will not work on integers, right? Won't work on floats, all right? So there's like functionality that you can think of as owned by these specific data types. And that makes sense because they do specific things, right? Here we might say we have this string. So I'm going to say print. Actually, I'm going to make a new string here. So I'm going to say this is a new curly brackets. So this is the format method. This might look a little bit weird. If we ignore print, though, and look at the expression inside the print statement, ultimately, we have a string with a bunch of characters and 2 curly brackets, right? Open and close curly bracket. The format method in Python will actually take whatever its argument is and replace any pair of curly brackets with it. So if I print this, I won't get this, or I won't get this whole text. I will actually get the string. This is a new string with string being taken and put instead of these curly brackets. Again, if you've used JavaScript, this is sort of Python's equivalent of template strings. It just doesn't use its own new character. There is an alternate Python syntax that lets you use an F before your string and then just like type a variable in here instead. So I could say, and like reference something else I wanted to throw in here. I'm not using that today just because the F can kind of get lost in there. It's a little harder to process. Any method, right, function that is owned by a specific type must be called as such, is called via a dot after whatever the thing it's acting on, right? So format is acting on this string. So we have this string dot format. We're calling the format method of this string, all right? Integers and floats don't really have the same method syntax that we've seen because an integer with a dot is a float that then has string characters if you try to make it a method, right? This doesn't really make sense. This just wouldn't make sense. This is a float up until this point, in which case it's just chaos. Floats with multiple dots would also be confusing. Numbers don't really support the same methods. They're pretty easy and rudimentary to deal with. So once we're through here, right, we've got some basic integers, floats, some strings. Basically, we've got some stuff we can kind of play with and start putting together, right? My goal here is to get through enough of the fundamentals that we can put them together to do a few things, all right? And make it a little bit interesting, a little bit interactive for you guys. There's only so much we can get through in an hour and a half, but we'll do our best. If anyone who joined in the last 30 minutes has questions, please put them in the chat. I will answer them as best as I can. No worries there. So anyway, let's move on past integers, floats, strings, right? We can now start looking at one other data type before we get to other behaviors, which is the list, all right? So a list in Python is kind of like what it sounds like in English, right? A list is just a ordered collection of values, right? If you make a list on your own, it's just a bulleted list of things in order, right? First to last. Python, a list is basically a container of other data types, right? So our underscore list, where is it? Lists equals, and a list is basically uses these square brackets to denote that we have a list, right? Anything between the square brackets, like we saw with strings, is kind of a member of the list, right? And the list syntactically is simple. We start out with one element, and they're all just separated by commas, right? So we can have 9, we can have 56.2, we can have 9,000. We can have a string if we want to, right? Lists are what we call heterogeneous, which means that in Python, lists don't care if they have the same data type for every element, different data types for every element, the same for most of the elements. Python, if any of you have used a language that's not JavaScript, but is a little bit more straight-laced or lower level, Python really lets you make your own mistakes and assumes you will make and structure your code correctly. So it will be okay with handling all these different inputs here, and it will just assume that your code isn't expecting a list of only strings, right? A list of only integers. It won't make assumptions about how you write your code, which some people like. Some people, I've had students who come from like Java, absolutely hate it. It really depends on your background. It's logical and algebraic operators languages exactly the same in that regard, except different syntax. To create new code, Matthew, we will get there. Functions are the easiest way to reuse code. There are also things like classes, which we will not get to tonight because that's a lot. Other commands are not all logical and algebraic operators. We'll get to control flow in a second, and some conditionals and stuff, which are, depending on how you use them, can be treated as logical operators. There are other functions in Python. Again, classes are the most obvious thing we won't cover that are a very easy way to reuse code. Learning object orientation in the first hour and a half of learning Python is nuts. for most people. If you want to, Matthew, you can table that question to the end. I can probably answer it in a longer form capacity.
Got it. Thank you. Very helpful.
Yeah, no problem. Yeah, I'll just punt that to the end, though, because especially for the beginner workshop stuff, we'll get through at least control flow and functions, and then it's a good segue into your question. Right, what else? Because there's a lot else, obviously, than what we can do today. So we have a list here, which is great, but obviously this doesn't do that much if every time we have a list, we need to like hard code, type these values out from the start. It's barely better at that point than writing like first equals 9, second equals 56.2, third equals 9,000, right? And storing them as different variables. Instead, I'm going to create an empty list. I'm going to call it empty because it's a good thing to name your values, your variables, something that makes sense. And so lists actually have interesting methods that probably the easiest, most intuitive methods we can look at to start out with that can, for example, take they can manipulate the list. All right. And when I say manipulate, I mean empty, right? In memory is going to point to this list without getting too much into the memory storage side of things, which can be a pretty deep subject depending on how you care about systems and their architectures. Empty, right, is a name. It basically points to this thing in memory. As I call methods on my list, it is actually mutating this list, all right? And I don't need to reassign. So if I call empty.append and I give it a value, let's say 10, I'm gonna get not this list, but I'm actually gonna get back a list of the number 10, right? A list of one element with 10 in it. I can alternatively do something a little bit more complex, right? And this is gonna be what we call iteration. Easiest way to think of iteration is really to think of a way to make a specific bit of code run many times. And the way I'm going to look at this right now is to look at an iterable, which is basically any Python element that is a collection of different objects. We can get to what that is a little bit later too. We're going to create what's called a for loop, right? If you've seen JavaScript, their for loops are similar. So I'm going to say for I in, this is a string, right? Empty.append I. I'm going to first run this, and then I'm going to explain what it is once I have the output, because it will hopefully be more obvious. Cool. So we get this long list of, I'm not going to count it, 20 elements or so. Broadly, what happens with how this for loop works is, first our for loop creates this temporary variable, right? And by temporary, it will still exist after the for loop technically. It will just keep getting reassigned as we iterate. So we say for I in, and then this collection of things, right? And for each element in this string, so T, H, I, S, space, etc., I will run this code once. And the way Python looks at this, technically Python, by the way, looks at indentation as 4 spaces. It's a very important Python concept. REPL usually always defaults to 2 regardless, because I believe for screen width reasons, right? If you have code and console, 4 spaces eats up a lot of real estate very quickly. But I must mention that before I leave it the way it is. It will help us read a little bit better to not go 4 spaces. So we can say for I in this, right, empty.append I. And what this loop does is it says, all right, first iteration, we're going to look at the first element of our string. And we're going to say, cool, I is lowercase t. And then every time in Python you see a colon, there's going to be an indent after it. And this basically says the following code belongs to this loop. Everything indented will belong to this loop and will run. So we will run any code from an indent to the next time we unindent, or go back 2 spaces, right? Like print, which is at the same indentation level as 4. We will do something. Whoops, I just collapsed that by accident. Right, and so what this will do is it will say, cool. So first time I is equal to t, we're going to append t to the end of our list. Append being a method that will just add an item to the end of our list. If you've seen JavaScript, it's equivalent to push, the array method push. The next time h, all right, cool, h is I now. We're going to add h to the end of our list, right? So we end up with each character added as a new element to this list up until the last character. And once we hit the last character, we exit our for loop and continue on with our code, right? Here we just print empty. I say this isn't a temporary variable just because technically if I print I, it's still going to be equal to the last character of our string. Python does not get rid of it, which can cause some weird issues if you're not looking for it. Again, people who've used other languages that are lower level or like statically typed or more regimented hate this. It is the way it is. I don't love it, but it is Python. So that's worth knowing. Generally speaking, this is iteration. All right, you can do it with a string. You can also do it for, let's see, item in empty. Print item. All right, and you can do it. You can iterate through a list as well. Here we'll just print every item on a new line, right? So for each item in our list, you'll print that item. So we start the first item, we say, cool, let's print 10. Then we jump back, cool, let's print item, which is now t, right? H, etc., including the spaces. Then we continue on, all right? For loops are generally pretty simple in Python. There are some optimized ways you can mimic their behavior. But this is kind of where we're going to start with for loops, all right? You can, for example, take advantage of this behavior and do some, this is just a syntax error from REPL, I think. This highlighting stuff, yeah, I'll ignore it. You can just kind of think of a for loop to your advantage, right? Let's say we had a list that had only numbers, right? We can use iteration to our advantage here and say, cool, let's say total equals 0 for number in our underscore list, referring to the thing I've already named our list, right? This list. We can say, cool, total equals total plus number, which I'll rewrite in 1 second, right? And then if I print total, this line will keep, right, taking a number, taking the old value of total, adding number to it, and then reassigning that to the variable named total. So very importantly, anytime you have the assignment operator, right? I'm not going to use the word equals sign as much as I can help it, because it's not an equality thing. Total is really sitting over here, but Python will evaluate this expression, get a value, and then reassign that to this name. All right, so there's no issue with total being on both sides here. This is using its old value plus a new value, overwriting once we're done. Right, again, this is an expression, right? We get the value out of the expression, then assign it to the name. So if I print total, then it should be, ends with 51, so that's right, 998, right? This is the total of these 3 things, right? Because we went through our list, we said, cool, let's add 9 to 0, then let's add 56.2 to 9 plus 0, then let's add 9,000 to whatever that sum is, right, etc. So we can start taking this iterative behavior and using it to our advantage, right? So this is called a for loop in Python, right? It's a simple way you can iterate, run some amount of code a number of times. Another way we can kind of change our code and how it runs, right? Instead of just having these expressions, which are helpful, obviously, and you use a lot of these, but usually you want to structure your code a little better, right? in 45 seconds, can anybody think of a reason this is better than manually adding all of the values on different lines? Cool. If you are
Could be a huge number.
yeah, if you are thinking, I don't want to type that many things at once, you're correct. In addition, though, like if this list has 1,000 elements, I'm not typing that out. And if you don't know how many elements it might have in the future, same thing, right? So we want to be able to run through and do all of this kind of regardless of the size or shape of what our code looks like. So the next thing we're going to look at then is just going to be what we call control flow, right? Or how we can control whether or not bits of our code run. All right, which brings up the last type we'll really need to look at here, which is the Boolean, which is simple, right? A Boolean is either equal to true or false. These are the two Boolean types in Python, right? We have true, we have false. A lot of expressions can resolve to a Boolean value. We haven't seen any of those yet, but think of something that looks like this, right? Print 45 greater than 80, right? This isn't an expression that gives us back a mathematical output, right? This is greater than, which is a yes or no question, right? Which is the easy way to think of a Boolean, right? It's a yes or no question. Is 40 greater than 80? No, right? That's false, all right? So this expression will work, but it will just give us back this Boolean value of false, right? If I invert it, we get back true, right? And so we can start using Boolean expressions to our advantage, right? We can use things, for example, like, let me jump down here and look at conditionals with a capital C, because that's what I've been doing. So conditionals are basically a way to say if and else, right? Which are the Python keywords we're going to be using. It's really a way to make your code run sometimes, right? Under some condition, or do something else. So for example, if 40 greater than 8, print 40 is definitely greater than 8. I'm going to put else, print 40 is not greater than 8. So the idea here is simple, right? If you notice, we have the same pattern as before. We have some statement, a colon, and then an indentation. So what we're saying after this colon with this indentation is this code basically belongs to our if statement here, right? So anything indented under if is only going to run if this is true, right? Which makes sense intuitively in English, right? If this is true, we'll do this, right? If isn't usually in English evaluating for false. Like if it rains, right, means if it does rain, right? If not raining equals true is a stupid way to say it, but you hopefully get it. Otherwise, right, else we will do this. But the way lines 65 and 67 are written here, these two lines of code will never run at the same time. All right, so I either have if or I have else. And of course, in this instance, right, we get this first line because 40 is definitely greater than 8. But if I change this to 80, right, now we will only get the second print statement, right? 40 is not greater than 80, which is also not uppercase, so it's easier to pick out, right? So we can use if and else to our advantage here to try to put together longer bits of code that do some more interesting things for us, right? Kind of write more complicated code that doesn't always run top to bottom, but might or might not run based on criteria. All right, so for example, let's just look at, I'm gonna make a quick list. So I'm gonna say for num in, I'm gonna make a new list. So I'm gonna say 1, 2, 3, 4, 5, 6, 7, 8, 9, 90, and 1,000 and 10,001. Why not? So we're going to just combine all these things together. And even though it seems like we spent a lot of boring time on really boring things for most of today's webinar, that's kind of the point, because once we have the building blocks, adding one thing and putting those together gets a lot easier. So let's say I have, cool, for number in here, if num modulus 2 double equals 0, which is a fancy way of telling Python if a number is even, print num, else pass. Pass in Python is a cool keyword that tells Python to not do anything, which can be nice. It is frequently used if you need an indentation but don't actually have code to put there. So for example, here I don't want to do anything with odd numbers. And this will give me a syntax error. Unexpected end of EOF while parsing, right? So it basically says line 75, there was nothing indented under else, and then I hit the end of the file, and there should have been code, right? Technically, I don't need this else at all. So I can just get rid of it. So you can say if num modulus 2 equals 0, print num. And now, here we get only the even numbers. All right, so now we're trying to quickly combine, right, a bunch of values, which are integers, into a container, right, a list, using iteration, right, a variable. We're using some operators and if to perform an ultimate action, right? I want to just print some integers, print some even numbers. All right. Alternatively, we can do something like print odd. Right. Instead, we will just get odd and then all the integers, even numbers, not integers, excuse me. Right. So this kind of makes some quick sense here as to what this is doing. If we want to take this a step further then, right, because we're now starting to be able to write, not really complicated, but more complicated, right, groupings of our code. We can say, all right, let's take this code and kind of wrap it up into one container with a name, all right? And that name, or what that sort of Python behavior is what's going to be a function, right? Again, I said earlier, a function is basically a body of code that can take inputs and give you an output. And it's ultimately one of the easiest ways to reuse code. So for example, function's a JavaScript keyword, apologies. Again, I said I would do that earlier. Python will use the def keyword to declare a function. Again, you see all these blue terms, right? These are all the Python keywords. There's a reason that most of these things are Python keywords. Def is the Python word that will define a function, all right? Def is followed by a space and then the name of the function you're looking for, right? So I'm gonna say def add 2. We'll take in an input, right? Python's convention for casing, as you've seen with all of my variable names, is called snake case, which basically is all lowercase with words separated by underscores. All right, so add underscore 2, not JavaScript, which would be camel case, right? Certainly not title case. In Python, title case denotes a class. So please don't do that. But we need an input here, right? And I can give it, like any variable, I can give it whatever name I want. So I'm going to actually call it num, just to prove something. All right, so add 2 num, and I'm going to return, surprisingly, num plus 2. And the return keyword is basically how you tell Python, if someone calls your function, right, the thing after return is what they get back, ultimately. We can have as many lines of code between here and here as we want, but ultimately whatever is here is what gets returned to the user. So if I call this function, right, I'm just going to say output equals add 2, 9. For an output, which should, no surprises, give us 11. All right, so this just took an input, added a second number, gave us 11. Right, if I want to say add 2 numbers instead of add the integer 2, first, second. I can say return first plus second. 9, 10. This should give us, now it gives us 19. All right, so our code will keep running, keep doing what we ask it to. And we can combine all these behaviors if we want into a function, right? And so to kind of bring this home, I'm going to make a slightly more complicated function that will do just that. All right, so functions. So on this line, I'm going to define one new function, right? And this is going to take in a list, right? Assuming it's going to be of numbers, and it will give us back the sum of the list. And yes, before anyone mentions it in the chat, this functionality is built into Python already. We do, in fact, have a sum function that will do this, but writing it on our own is a good way to combine what we've seen already. So def list sum, I'm going to take in a underscore list, being that list is a reserved word in Python. If you look at it, right, it turned a different color than black, so it's not something we can use as a variable name. So if I think about a list, I can think, all right, it's got a bunch of values. We got a total before. It's basically as simple as creating somewhere to store our total and then manipulating it as we go through our list, right? So if we're numbing a list, total plus equals num. Plus equals is a quick way I can rewrite this syntax. So instead of putting total twice, I'm going to say total equals total plus number. This is what's called the increment operator. It will just add this to total's old value. It's very useful. And then I'm going to return total. Notice real quickly that return is not indented. If return was in here, you would actually just return total plus the first number, and that's it. In Python functions, you only get to return once. The minute you hit the return keyword, the function is over. So this wouldn't, for example, return me one value for each item in the list. It would just add first element to 0, return whatever that was, and the function would be done. All right. So you need to play with your indentation to make this work. Otherwise, you'll get weird indentation errors. Generally, if I call this, right, and I say print list sum of this, which should be slightly over 10,090, it should be about 10,115 or something, we should get Ben, I will send you a follow-up email if you got to go. No worries. With my email and video and this code, I will probably have some other links of useful places to start practicing, etc. The easiest way, I say, for you guys to start practicing is, at least the way I learn, is fooling around with the bits of code you have seen thus far and making it do things you want it to. If that creativity isn't something that comes as easily to you to like, yeah, let's make it do this. I can point you to other places, but I'll make sure to send you guys my email and stuff as well. No worries. So, right, if we look at this, and again, this is just an expression inside print, right? We have our function call with our argument, just a list. And this gives us our output, right? 10,136. I was off by like 15 or 20. Right, we can start adding these functions up and making them do slightly more interesting things, depending on what we really need to do. All right. And at this point, writing the code becomes a little bit more open-ended, right? We've gone through a lot of the really basic Python behaviors. But more than this is partly use case dependent or can become a little bit more complicated syntactically. depending on what you want to do, right? These are all the basic building blocks of Python. Once you have the basic types, operators, some of the other keywords and built-in functions, and then the ability to make your own functions. So it being 7:16, I said I would try to do this. I want to open up the last 15 or so minutes to questions. There are not so many of us. People cannot use, you can use the chat or you can use your mic at this point. Either one is cool with me. Does anyone have any specific questions or things they'd be interested in learning about, looking into, that they want to do with Python specifically? Or if not, I'll circle back to Matthew's question real quickly. So Matthew, the only functions the only code you can use. So what do you mean by, really quickly, to create new code? Like ways to compartmentalize your code so that you can keep reusing it without typing out more code? It's technically not creating new code. It's just writing less code that's redundant.
Okay. I guess the way I'm looking, and I could be looking at it totally wrong. Please tell me.
Yeah, sure.
I feel like there are built-in commands to languages, but then functions allow you to expand ability.
Yeah, so every language has its own library of built-in stuff. Python has a ton of it. As I mentioned, there's a sum function, right? That will take in whatever, right? And it's just a built-in function. Python has a lot of built-in functions, right? Some of this 21, right? Basically, there's a lot of operations people do over and over and over and over and over that most languages have decided it's good to just include in it, so people use the language primarily. Python has a lot of this. It also has a lot of built-in functions and modules that you can use what's called the import keyword. That will give you added functionality, right? There's like a math library that has math functions. There's like one to interact with your operating system. There's a ton of that. There's a lot of built-in functions that are already written, but you can also define your own functions just as easily, usually for repeated operations, right? Things you're going to do more than once.
Yep.
As I mentioned earlier, the other way in Python people frequently do it is what's in object orientation, which is called like creating a class, which is kind of like making a function, but it's a lot more in depth. It's basically creating your own type. So for example, let's say we have strings, right? Or lists, which have not just data, but their own methods to act on that data. Creating a class is like, you can do that basically, right? You can store data and methods to act on the data. It's how a lot of Python code ends up organized in production. So there's other ways you can reuse code or group it together, and it partly depends on what you're doing. Realistically, the code reuse is almost always functions and classes and their methods. Okay. Otherwise, it's a lot of different combinations of either, iteration and control flow and conditional statements. There's error handling control flow, which is to try and accept keywords. A lot of that stuff as well, but it's usually built-in library syntax and user-created functions working in a specific way, usually with a heavy dose of some like framework that does something else. There's a lot of web frameworks and stuff, for example. Like we just started a course, software development, which is like an intro course. It's just like a good thing because I've been working on it forever. That uses a web server framework. And that's not just built-in syntax. It's like a third-party library's syntax and classes and functions. That's kind of like an addition on top of normal Python, which is the only reason I mention it is because realistically you get a bunch of that as well in like, real useful application code.
Like Flask and Django?
Yeah, exactly. Flask, the one I was actually thinking of, which is technically classes and functions, but it is not like user defined. It's like very, heavily worked on abstracted stuff from the library that deals with stuff that is really chaotic and complicated otherwise.
Got it. Right. Yeah, got it. Okay.
But that's kind of the long form, like didn't want to do it in the middle of the webinar type answer to that question.
Sure. No. Thank you.
I think most languages are similar in that regard. Like there's so many languages. I can't speak for certain. Most popular languages are some combination of, they might call it something different, like an interface or something where it's a combination of an object-oriented thing and a functional thing and basic, basic operators and control flow and stuff.
Yep.
Obviously, every language is written very differently, but like they all basically have the same bits and keyword. Even some of the same keywords, but like bits and pieces depending on how you do them.
Okay.
Obviously, we don't manage memory here in Python, but like it's usually otherwise pretty similar.
And if you're doing web development,
yep,
you would definitely need to, like, could you just do that with Python and Flask, or you'd have to know a front end language also, or a front end component?
There are technically Python, and I'm going to say technically, there's technically Python frameworks that can create an interface using Python that like generate HTML and stuff.
Yep.
If you want something to look legitimately good or like modern, it really usually shouldn't be done with Python.
Yep.
At the very least, the amount of control you'll get out of it isn't great. Usually with a web server framework, Flask Django or something, you'll get at least some HTML and CSS.
Got it. Okay.
They're easy to learn, like literally. I mean, they're really deep and can be really deep, but the basics take like 50 minutes to learn. I usually lecture the two of those in one day, and then have students like take a day to just make something and see what they can do. So they're like pretty straightforward syntactically. They're just deep with like different properties and keywords.
Okay.
But I forget the other. There's like I've used it. Dash is like a dashboard framework for Python that kind of lets you write UI elements as Python objects that it kind of creates for you, but they don't look good. They just work.
Got it. Okay.
Usually you're going to want HTML, CSS, and JavaScript for web development in some capacity.
Yep.
You can get away without JavaScript if you don't need something crazy nice. But again, the sort of barrier for entry, right, is again the software development intro course, just because it's the intro way to do that basically. Is that course you can take 8 classes and theoretically make an end-to-end web app, but there is no JavaScript, so it's all HTTP requests from a web page back to Python. Which works. It's just more like a Wikipedia style website than like a cool interactive web app like a chat app or like Gmail or like something more interesting.
Got it. Okay.
I mean, web development is obviously kind of a rabbit hole. There's a lot you can do with it.
Yep.
I don't know if you have background or have used other languages or whatever.
No. I mean, I've online looked at a lot of courses,
sure.
but I wouldn't say. I mean, I played around with some CMSs, Joomla, WordPress. That
makes sense. There's a lot of tools you can put together most of an app with out there relatively easily. Usually I think obviously like it's my job. Like you should write some amount of code if you want it to do anything interesting. You can get a long way with like mostly out of the box solutions.
Yep.
Things like Firebase, for example, and other app stuff.
What was that one you said?
What
was that one that you said just now?
Firebase. Google Firebase is their like cloud-hosted, simple to use database solution that has a lot of different options. I use it for software development, of course, because it's easy. It's just like they create it for you, and it's just get and post requests. It's mostly it's like a document store, so it's not like a SQL database. It's more basic than that. You just save like a dictionary-like object and then request it when you want it. It works surprisingly well considering that it's free and involves almost no time on your part.
Okay.
So it's worth looking into. It's so easy to use. Like, again, I teach it to people who have used code 2 nights a week for like 4 weeks. and it is really not, it's really straightforward. But otherwise, if there aren't web dev frameworks, you got to use something that's like one of those website solution things. If any of that helps.
Yeah, very helpful.
Yeah. Again, I'm online at least until 7:30, so another 5 or 7 minutes. If either of you guys who are still on the call have questions specifically. Free interactive courses being offered, mentioned at the beginning of this class. How do I sign up? All right, Hernando, I will include with my follow-up email that I will send either today, maybe tomorrow morning, depending on Zoom's video compression and how long it takes, because I'm going to eat right after this. I will include all of the relevant links there, including to our admissions and the relevant people there. If you want, you can give me your email, and I will have Phil reach out to you tomorrow to expedite things. But otherwise, I'll also include my contact info in the follow-up. So if you guys have questions about anything, like, let me know. Again, I am quarantined and hanging out, so like I will respond most of the time. It's also my job, which helps making me do it.
With quarantine, easier for a coder? A lot of your stuff is online.
Teaching was a lot harder. I thought would be a lot harder than it ended up being. Just like the realities of code development and everything is it's all the infrastructure is in the cloud or made to be done remotely or by large teams like that anyway.
Yeah.
It was pretty straightforward. Like writing code locally as opposed to anywhere with other people or whatever is relatively like all you need is an internet connection. It's pretty good. I don't need the office in any capacity, although it's good to like see my students in person.
Nice.
But I feel like I would have written more code in quarantine had it not felt too much like work.
Well,
it's
yeah,
like
right,
most things, if you do it, if you do anything like it for work, you're not going to do it on your own.
Dude, I see that all day with my work. It's like I can't.
Yeah.
It's actually interesting stuff, and I can't, sit down and do it.
Well, there's like so many projects I would love to do, but like the minute work is done, it's not what I want to do. Anything that is not a computer is what I want to do.
Right. Especially with everything going on with the quarantine and life just being totally crazy, you just want to veg out a little bit and relax.
It's true. I also want to do anything that involves like mental acuity. But cool. Anyway, Hernando, if you don't send me your email before I close the call, I will just send you the follow-up email, including mine. I believe my email anyway is going to be the like response email for the meetup thing that I send out.
Okay.
So no worries if you don't send it, but I will include all the relevant details. If I missed something, please email me back and let me know. I'll send a follow-up to everybody with like if the video link is dead, if the code link is dead, whatever. Because I'm assuming there's some people who didn't show up for the call today for whatever reason too, once I said there was going to be a recording, because that's how webinars always work, who will be needing those materials especially. All right. Any other questions?
No, this is great though. Thank you.
Cool, no problem. If you have them between now and like when my email stops working, please feel free to reach out. I'd be happy to answer them.
Awesome.
Otherwise, thank you guys for attending.